What is the objective here? The objective depends upon what kind of goals we have. The first kind is non-preemptive goals, where we are saying that no goal is inordinately more important than any other goal. In which case, we will minimize the weighted sum of the deviations from the goal values in the direction that is not desirable. So if we are saying that the cost should not be more than a certain amount, then we will penalize D2 plus. Or if we are saying that the toxic water should not be more than a certain amount, then we will penalize D1 plus or minimize D1 plus. We don't worry about the D1 minus because that's just telling us that the toxic waste would be even lesser than our goal value, which is great, fine with us. So therefore, we minimize a weighted sum, which is to say minimize W1 D1 plus W2 D2 plus. So therefore, here we are. The entire problem now looks as follows, where we have the decision variables K and L, but also in addition, the deviational variables are decision variables. We have the hard constraints, and then we have the two goal constraints. And the objective is to minimize W1 D1 plus W2 D2 plus. How do we go about selecting these weights? We will see. Let's go to Solver and look over there. So look at the sheet on Solver where it says with goals. What we will do here is for the toxic water, the first three are hard constraints. The three grade copper constraints are still there as they were earlier as hard constraints. But the toxic water produced constraint on the right hand side, we are saying instead of 6,000, we are willing to accept a value which is a little higher if required. So therefore, it is equal to 6,000 plus some amount by which it might have to go up. And then we also say it could go down if required. And the moment we do this, the inequality that we had becomes an equality for us. Similarly, for the toxic water, for the budget or the cost constraint or goal, we would say this is equal to 12,000 plus D2 plus minus D2 minus. And the objective function would be equal to then D1 plus, let's begin with D1 plus D2 plus, essentially saying that the weight given to both of these deviations from the toxic water produced goal and the budget goal are same. It's 1 each. With that, let's try to solve this and see the kind of solution we get. So we have the objective value is in cell D11. We are trying to minimize that. The variables that we have are now K and L, but not just those. We also have our deviational variables, so we will add them. The D1 plus, D1 minus, D2 plus and D2 minus. Separate the two sets of variables with a comma because they are not contiguously placed on the spreadsheet. And then here are the three hard constraints, and you also have the first goal constraint and the second goal constraint. Make sure that the variables are specified to be non-negative and you are using the simplex. And solve. Let's see what we get. We get a different solution. We get the number of months that you should run the Kansanshi mine is 2.14 months and the Lumwana mine is 5.35 months. And as a result, the toxic water produced is 7392.86 and the cost is 12,857. So this looks like the same solution that we got when we minimized the cost. Where the deviation from our first goal, which is the toxic water produced goal, is 1392.86, essentially saying that instead of 6,000, you have a toxic waste produced or water produced of higher amount, which is 7392.86. Similarly, the cost Now, over here is not 12,000, but more than 12,000, 12,857. And as a result, the deviations, the two deviations are over here for the toxic water produced plus the deviation for the cost gives you a total of 2,250 as being the total deviation from your two stated goals. Now, by giving these equal weights, we are saying that a deviation of 1 unit in toxic water produced means the same thing to us as a deviation of 1 unit in the cost that is incurred. We might want to weigh these differently because firstly, because the units are not same, and secondly, because it may not mean the same thing to us that the toxic water deviation of 1 unit is the same thing as the cost deviation of 1 unit. So therefore, instead of taking the weights to be 1 each, we could take different weights on the two deviations. So go to the next sheet which says goal programming with weights, GP weights, and let's look at this one. So we have the 3 hard constraints here. We have the 2 goal constraints here, but let's look at the changing the objective function to be such that we give a higher weight, let's say, to the toxic water produced. So we say, well, the toxic water produced gets a weight of 2. Any deviation from the stated goal gets a weight of 2, while the deviation of cost gets only a weight of 1. So therefore, our objective function is twice into D1 plus D2 plus. So we are giving more importance in this case to a violation of the toxic water goal. With that, if we solve, let's go ahead and call SpunSolver to solve this. We again have our objective function set as cell D11. We are trying to minimize that. We have our variables k and l and also the deviational variables. And here are the constraints that we had earlier and the goals as well. The only thing that has changed is that we weighted the objective function differently. So let's solve this and see what we get. We get a completely different solution here. What we get here then is k is 5.625 while L is 1.875. And as a result now, there is no deviation from our toxic water goal because we gave it a higher penalty, or we penalize the deviation of from this goal with a multiplier of 2, and therefore it is pushing us or giving us a solution where this goal is not violated. While the other goal is still violated, the cost goal is still violated, that goes up. Instead of 12,000, it goes up to 14,250, where D2 plus is then 2250. So the total deviation now is 2250, but all of that deviation is in the budget. So in a nutshell then, in goal programming, what we are trying to discover is different possible solutions that we can work with. Which solution we choose entirely depends on what seems to be better, because there is no single optimal solution here. So if, for example, the toxic water produced goal was very, very important to us, then this solution would probably suit us better than the other solutions that we looked at. However, of course, in each of these solutions, one should note that you are producing different quantities of the 3 grades of copper. So from the options that we get in this manner, we will then choose the one which suits us the best. We could also give a different weight, for example, than 2, or we could give a higher weight to the second goal that we have. And similarly, if we have multiple goals, more than 2, we can do a weighted sum in this manner to come up with different solutions and choose the one that seems to be the best.